Hello everyone, my name is Phaedra and today I'm about to present you problem number 14, ruler trick. The problem statement is, place your ruler on the edge of a table and throw a ball at its free end. The ruler will fall. However, if you cover part of the ruler with a piece of paper and repeat it, the throw, then the ruler will remain on the table while the ball will bounce off it. Explain this phenomenon and investigate the relevant parameters. So about the qualitative explanation. When the ball hits the ruler, part of the ruler on the table tries to lift, and air tries to insert under the paper. Since the force is sudden, the air does not have time to enter under the paper, and a vacuum is created under the paper. The atmospheric pressure force on the paper is greater, and thus the impact force from the ball is not able to lift the paper. Now, let's analyze the motion quantitatively by separating it in steps. For the step 1, we have the free fall of the ball on the ruler from a height h with no initial velocity. For the step 2, we have the collision of the ball and the ruler. The ball hits the ruler with a velocity of v1, which is given by this formula. About the step 3, we have that the ball bounces off the ruler with a velocity of v2, and the coefficient of restitution is E, which is given by this formula. About the quantitative analysis, the change in velocity during impact is given by this model. We also know the impulse j, so knowing the duration of the collision, we can calculate the maximum impact force of the ball on the ruler, which is given by this formula. About our second approach, we establish a natural frequency for the system of two bodies, and then the total impulse J will be given by this formula. The impact force will be PJF, so combined, if we know F, we can calculate the impact force, which is given by this formula. About the quantitative analysis, if the force acting on the paper is F ATM, which means atmosphere, and is equal to PS, where P is pressure and S is the surface area of the paper, then for the phenomenon to proceed, when F impact is maximum, we need the F impact to be less or equal to F atmosphere. This happens because the paper rests on the table and on the ruler. Upon a sharp strike on the free end of the stick, air cannot go under the paper quickly enough to compensate the atmospheric pressure on top, so the air cannot get under the paper, which acts as a vacuum. By using this formula, we can calculate the minimum surface area of the paper for a given ball mass and initial height, and show the relationship between the independent parameter mass and the surface area. Moving a bit further, we can see that the problem statement suggests that the ball bounces off the ruler without breaking it. So we can use this model to calculate the maximum torque for the ruler not to break, which is the following. But also in our experiments, we ensure that the ruler won't break by using a steel ruler. The relevant parameters of this phenomenon are the independent parameters of the ball mass and the table. The dependent is the paper size, and the control variables are the height of the toss, the ruler placement, and the ruler material. So the hypothesis about the table is that if we conduct the experiment on a table with holes, air will be able to get underneath the paper and the phenomenon will not proceed. And the hypothesis about the ball mass is that using the theoretical formula, we will be able to calculate the minimum surface area of the paper needed for each mass. As the mass increases, the surface area will also increase. This is our experimental setup. Here we can see the free fall adapter, so that it was not so that we didn't use our hands, and we had control these parameters. So we had no initial velocity or angular momentum. Here we can also see the other instruments that we used: the metal balls, the steel ruler, the sheets of paper, the ball release mechanism, the table with the holes, the compact table, and the camera. So, if we conduct the experiment on a table that has holes, the phenomenon will not proceed because the air can get underneath the paper. So, our first hypothesis is confirmed. We used Tracker as a video analysis and modeling tool so that we could measure the duration of the collision and also calculate the theoretical value for minimum paper surface area. And this is a table which we obtained by Tracker with the experimental results. Firstly, we can see the ball masses, and then the collision duration, which was obtained by Tracker, the theoretical S and experimental S, both in centimeters squared, and the error percentage. Here we can see some videos of our experiment, and also some graphs about the velocity and the distance from the ruler of its experiment. In this graph, we can see mass versus the paper surface area. And here we can see that the black line is our theoretical line, and the red line is the experimental line. We can see that the ball mass to minimum surface area of paper in this graph. So we can see some big declinations between the theoretical and the experimental line at first. This happens because the minimum experimental value of the paper can't be less than approximately 45 centimeters squared, because it must cover the surface of the ruler. However, the theoretical model gave us smaller values, thus the inaccuracy and the percentage of the error. So about our second hypothesis, it was also confirmed because the theoretical model does not apply when the calculated area is smaller than the area of the ruler. So although the average error of all values was 23, which is a big error, the average error for values when the model applies is only 5.43%, which we can all agree that is a very small amount. So the average error is 5.42%. Some error analysis that the errors can be attributed to the accuracy of the duration of the collision, which is obtained by Tracker. Also the accuracy of coefficient of restitution value, which is obtained by the bibliography, and the accuracy of the theoretical velocity calculations. Now let's do a full summary of the report. Firstly, we explained the phenomenon qualitatively, and then we moved on to develop a quantitative theoretical model that predicts the relationship between the mass of the ball and the minimum surface area of the paper for a given height. Then we also talked about the parameters and the hypothesis of the problem, and we explained the experimental setup that helped us reduce the human errors. And then we analyzed the two experiments that were done and presented and the data acquired. Lastly, we talked about the possible errors of our experiment. Here we can see the references that we used in our study. And thank you for your attention.